Hi guys, welcome to Mathematics for Engineering 3. This is an international program for students at Kasetsart University. It's all about ordinary differential equations, including Laplace transforms. So basically how to solve the ODEs. But, if you don't know what ordinary differential equations are, wait for it, okay? uh, this is a bit about myself. I That's my name, Udomsak Rakwongwan, but you guys can just call me M or PM or whatever you like. I got my bachelor in mathematics in pure math at Kasetsart University with the highest GPA in that year, and then I got my master's. I went to do my master's at King's College, London, in financial mathematics, and I also got the highest score there as well. And I also did my PhD in financial math at the same university. I specialize in asset liability management and some pricing. So if any of you guys are interested in pricing or in finance, how to apply mathematics to finance, just contact me, okay? We can talk about that. Well, before we start, let's make it clear. If you have any problems, okay, if you come across any questions, any problems, or whatever, just contact me, okay? Don't hesitate. You have got my contact, okay? You've got my email, you've got my, some other contacts as well. Just contact me. Don't hesitate. Just say, hi, I am a student in mathematics for engineering 3, and that's my name, and this is my problem. Or if you are watching this entertaining video and you have got some some problems, some questions, just text me, okay? Hi, M, I don't understand this. How did you get that? Just ask me. I am willing to help, okay? uh some of you might be watching this video at night, at midnight, 1 o'clock in the morning. It's likely that I'm still up, okay? So if you have any problems at midnight or at 1 o'clock in the morning, just text me, okay? Just don't hesitate, just text me. If I am still up, I'll reply, okay? If you text me and I don't reply within a day, just text me again, okay? Maybe I just forget to reply. Sorry, I forget things quite a lot. But just know this one thing: I am willing to help. Okay, I'm here to help you to understand the materials. Okay, to understand the ODEs. So if you are willing to learn, just ask me questions. Whatever problems you have, I'm willing to help you to solve it. Well, let's start. Okay. Talking about differential equations, the first thing you should ask me is, what is differential equation, right? So here is the definition. A differential equation is an equation which relates one or more functions and their derivatives. Okay, so it's actually an equation that relates one or more functions and their derivatives. So let's look at this example. If I have here s equals to t, let's say x is a distance and t is time. So this says that the distance is twice of time, right? So if time is 1, distance is probably 2 meters. And if the distance is 2, if the time is 2, the distance is probably 4 meters, right? And that shows the relationship between the time and the distance, s and t, right? But that's not differential equation because there's no derivatives, right? But if you look at the second equation, is ds by dt equals 2t. And that is an equation that relates, right? T and ds by dt, which is a derivative. Okay, so our whole course is to solve these, kind of differential equations. So the problem here is, what is s? For this problem, it's pretty easy. You can just integrate, right? And you get the s. But if we have like a really complex differential equations, what should we do about that? And that's the whole idea of this course. So let's talk a little bit about ds by dt. Just to remind you of calculus 1. You know that the derivative is actually the rate of change, right? It's actually the rate of change. The rate of change at a particular point, right? So the rate of change of distance by time is actually what is the velocity or speed, right? So here it's actually saying that the speed is actually the twice of time. So as time increases, the speed increases as well, but as twice of time. Make sense? Sense? So in reality, we might not be able to write equations to explain problems without using derivatives. So I mean, we might not get equations like x plus y equals 10 and then we solve for x and y blah blah blah. That would be too easy. In real life, the equation would be really complicated. Lots of derivatives, lots of some other exponential, logarithm, and those kind of things. Okay, so for example, if you look here, the natural growth, it can be described as dn by dt equals rn. Okay, when n is the population. So it's saying that the rate of change of population depends on the current population and some r is a constant r. And that's one of the models that used to describe the growth of the population. The second one is a simple harmonic motion in physics, right? And that equation is used to describe the simple harmonic motion when x is the distance and t is the time, k and m are constants. And the next one is wave equation, right? The wave, and this can be described by this equation. See, it involves the second derivative, and you can see y is a function of x and t, and that's, we have the name for that later. Okay, so the next thing I want you to know is just the terms, just some jargons, which are dependent and independent. So what are they? So we have two types of variables. One is dependent and the other one is independent. So if you look at this equation, if you look at, okay, let's first look at dy by dx. The y here is called dependent and the x here is called independent. Okay, if you find the derivative of y by x, the y is actually the dependent variable and x is the independent variable. So in this example, the independent n would be the dependent and t here would be the independent variable. Similarly here, x here is the dependent and t here is independent. Make sense? And for the wave equation, y here is dependent and t here is independent and x here is also an independent variables. Cool? Cool. So right now we know what differential equations are, right? And we know dependent and independent variables. Okay, so next, the differential equations can be, grouped into two types. The first one is ordinary differential equation, or ODE. So it's ODE. It's a differential equation with one or more dependent variables, but it's only one independent variable. This is the important part. Sorry, it's only one independent variables. But for partial differential equation, or PDE, sorry, it's actually, I should have more than. It's actually the same as the ODE, but it has more than one independent variables. Okay, there's some typos there. So these are the example of the ODE and PDE. Let's look here. If you look here, y double prime is actually, the second derivative of y by x. So the y is dependent variable, but x is independent variable. So it's only one independent variable. You can say that, right? So the second one, we have only one independent variable, which is x. And similarly for the next one is x here, right? In x here. Here we have two dependent variables, which are y and z, right? Here, y and z are dependent variables, right? Right? Because the thing up there, the thing, at the top of the derivative are dependent variables, but the thing down here is independent. Okay, so in this example, y and z are dependent variables, but x is independent variables. Also, it means that there's only one independent variable, isn't it? Right? So these differential equations are ODEs. Okay, so let's look at the PDE. Here, this one, u is actually the dependent, but x and t are independent variables, right? So there are more than one independent variables. So this equation is PDE, or partial differential equation. Okay, the second one, we have that x and y are independent variables. So this is PDE as well. And here is t and x are independent variables. Is that clear? So right now we know the difference between the ordinary differential equation, or ODE, and partial differential equations, or PDE. Okay, so the next topic is okay, before we proceed to the next topic, I'll let you know that in this course we only look at the ODEs. Okay, so we're solving the ODEs in, but if you want to know how to solve the PDE, you can go to some other courses. There are some, courses for partial differential equations. They are a lot harder, to solve the PDE. Okay, the next definition, the next term that you need to know is linear versus nonlinear. Okay, a differential equation is linear if it can be written in this form. Okay, so remark, if you observe this form, there should be some remarks, right? First, no y squared, y cubed, or y to the fourth on blah blah blah. There are no such terms. So if you have y squared, y cubed, and blah blah blah, those are not linear, or they are called nonlinear. Okay. Second, you can't have dy by dx squared, or dy by dx cubed, blah blah blah, right? And here is for any orders. So just to say it in some other words, is that you can't have the the derivative squared, or derivatives cubed, or the power of derivative. You can't have those, otherwise it's not linear, right? Here you can see is dn by dx, sorry, dy by dx, the nth derivative, but there's no squared, right? So you can't have that. And the last thing is that the coefficients of the derivative have no y. Okay, no y. So as you can see here, these are the coefficients of the derivatives. You can see that it's a function of x. So you can't have y as the coefficients of the derivatives. Make sense? So let's look at some examples. Here, which of the following is linear? Which of the following is linear? A, is it linear? Okay. Are there any y squared, y cubed? No, right? Are there any, the power of derivatives? No, right? And if you look at the, the coefficient of the derivatives, there are no y's there, right? So this one is linear. B is not linear. Why? Because the coefficient of the second derivative is y. But as you can see here, the coefficient are the function of x. So you can't have y as a coefficient. Okay? So the next one is alright. Right? It's linear. You have, even if you have y here, but so what? We can have y, but we can't have y squared. Hence. So that leads to number D, that D is not linear because we have y squared, right? So E is linear, right? Because there's no y squared, y cubed. We have the second derivative of y, the first derivative of y, no squared, no cubed, no powers, and the coefficients of the derivatives have no y's, right? So it's linear. F is not linear. Why? Because here is dy by dx squared, right? So we have the square, the square of the derivative. Makes sense? And similarly, for G, we have the dy by dx squared. So it's not linear. Makes sense? So the next one, this one is linear. Don't forget, guys, y double prime is actually dy, the second derivative of y by x. So it's linear, right? There's no y squared, no y cubed, blah blah blah, right? So I isn't linear. Why? Because here is the first derivative of y squared, which makes it nonlinear. Okay, and the last one, this one, is also not linear, non-linear. Why? Because you have got the y squared, oh sorry, you have got the second derivative of y here, but the coefficient of the second derivative of y is y prime, right? Which is the, you can see it as y, right? Because here from the definition it must be the function of x, right? But y prime, you can have y in y prime, right? So it makes this non-linear. Cool. Okay, the next topic is the orders. So it's another, it's another it's another term, it's another jargon in this course. So this video is more about definitions. What are these, what are those? Okay, this is order. So what do you know what order is? The order of a differential equation is the order of the highest ordered derivative appearing in the equation. So let's look at this example. Here, you have the first derivative, right? For a, you have the first derivative. So this is the derivative of order 1. Make sense? For the second one, we have the, the highest order of the derivative is the second order, right? So the order of this differential equation is 2. So this is the differential equation of order 2. Okay, so the order is actually just, the highest order of the derivative. So for C, the order is 3. It's the ODE of order 3, or of the third order. For the next one, D, I'm gonna come back to that later. Okay, because it's not a useful form. It's the form called differential form, and we're gonna look at that later. Actually, I think you already know that from calculus 1, but you probably forget that already. So we're gonna talk about that later. I'm gonna come back to that. So the nth order ODE can be written as f of this. So why? For example, if you look at this differential equation, it's actually 2y double prime minus y prime minus 1 equals 0, right? So in that case, you can define f of x, y, y prime, and y double prime as 2y double prime minus y prime minus 1. And then you can write f of x, y, y prime, y double prime equals 0. So saying this is the same as saying this when f is defined in this way. Okay, it's just a fancy way of writing things in mathematics. Is that good? Cool. So the next one is solutions. As I told you, the whole course is about finding solutions for ODEs, right? So first we need to be on the same page, about the solutions. What solutions are, right? So a function phi defined on the interval I with at least n derivatives which are continuous on I is a solution of the nth order differential equation, this differential equation, if this is 0. What does it mean? It simply means that if you plug in phi in y, you have 0. Okay, so let's look at an example. So to show that y equals e to the minus half of x is the solution of 2y prime plus y equals 0. So first, this is the same as phi, right? So I'll look at y first. Y is e to the minus half of x. So y prime, what's y prime? So is e to the half of x, and by chain rule you get minus half, right? Just from what you learned before, right? How to differentiate the function. You need to use the chain rule here, right? So is minus half of e to the minus half of x, and then you have that 2y prime plus y is 2 of minus half of e to the minus half of x plus e to the minus half of x. Make sense? I'll just put the y here, and the the y prime that I have computed here, right? So this is actually what, second, this is actually minus e to the minus half of x plus e to the minus half of x, and this is actually 0. So we can verify that 2y prime plus y is actually 0, which is the same as here, right? So we can conclude that y equals e to the minus half of x is the solution of 2y prime plus y equals 0. That's it. Easy, isn't it? Okay, let's look at another example here. Show that this is the solution of that. Okay, you probably say that m, this is no y, it's not y equals blah blah blah, but it doesn't really matter. It doesn't really matter. You can you can just somehow use this to verify that the same thing, right? You don't need to. You can if you want, you can change this to y equals something, and then you plug in y and y prime in here to verify the equality. But you actually don't need to do that. You just need to use this information to verify this equation. So how? First we have x squared y plus y squared minus 4 equals 0. And then I take the derivative throughout the equation. So what I have is the derivative by x of x squared y plus y squared minus 4 equals 0. And to take the derivative, the first term would be x squared. The derivative of fg is f dg plus g df, right? F dg plus g df, right? The derivative of fg is actually f dg plus g df. That's from calculus 1, right? So you get x squared dy by dx plus y dx squared is 2x plus 2y dy by dx, and then minus 0. The derivative of constant is 0. and then I'll rearranging the term. So I'll get that x squared plus 2y dy by dx plus 2xy is 0. Then I have that, if I multiply this equation by x, I'll get that x cubed plus 2xy dy by dx plus 2x squared y equals 0. Okay, and this actually verifies this. So I can conclude that x squared y plus y squared minus 4 equals 0 is actually the solution of that differential equation. Make sense? Okay. The next one. Okay. So this is when you have y. So I'll find the first derivative. Y prime is 12 of x squared plus 24. And y double prime is 24x. And of course, y triple prime is 24. And then I'll try to verify this equation. How? I'll look at y triple prime minus y prime. So what is it? It would be 24 minus y prime is 12x squared plus 24. And that would be 24 minus 12x squared minus 24. And that is minus x squared, which is the same as that, as you can see. Right? So right now I have verified that if y is this, to verify that this y is actually the solution of this. Make sense? Okay. The next topic is the differential forms. It's the one that I have skipped, right? So we're gonna look into that. The first order differential equation in this form, or in this form, as you can see, has a differential form as this. So how to write the differential form? Let's look at this example. Write the following ODE in the differential form. So I've got this ODE, right? Is actually x plus 2 dy by dx minus 4x squared y plus e to the x equals 0. So if I want to write this in differential form, the first thing you need to know is that dy by dx is actually y prime, right? Actually y prime. So the differential form is dy is actually y prime dx. Make sense? If you don't know this, you go back to calculus 1, the last topic before midterm, which is called differential forms, and you can use this to do some approximations if you remember, right? So it looks like you can multiply dx to y prime, but it's actually not that. Okay, but I think it's quite alright to think that it is for for convenience, but it's actually not. Okay, so dy by dx is y prime. So dy is y prime dx. Looks like. Okay, so how can I convert this equation into the differential form? It's pretty simple. You look here, is x plus 2 dy by dx is 4x squared y minus e to the x, and you have that y by dx is 4x squared y minus x e to the x divided by x plus 2. Then I'll have that dy is actually 4x squared y minus e to the x divided by x plus 2 dx. Right? Right? And if I just move the dx term, sorry, I can just move the dy term to this side. What I get is 0 is 4x squared y minus e to the x divided by x 2 dx minus. So as you can see, this is actually the mxy. You know, if you compare this with this, so this is actually the mxy, right? And the other one, this minus 1, this minus 1 here is actually nxy, right? So we have this differential form. Does it make sense? Okay, so the key of, you know, changing the differential equation to differential form is, okay, so in this course we, you know, mostly work with the differential forms. Okay, before I go to the next topic, I'll go back to, you know, where we were here, the, you know, question D. So here I'll first convert this, which is the differential form, back to the usual form. Now if you look here, move my, if I just look here, I'll have that dy by dx is, okay, I'll do it slower. Can I write here, you know, to have more space to write? I'll get that 3x squared minus 1 dy is x plus y x, and in that case I have that dy by dx is x plus y divided by x squared, right? And, you know, we get back to the differential equation, you know, the normal form. And as you can see, we have the dy by dx, we have y, there are no y square, y cubed, derivative square, derivative cubed, you know, there are no y in front of dy by dx. So in that case, we can say that this is linear, right? This is linear ordinary differential equation, and the order of this equation is 1, order 1. Make sense? The order is the highest order of the derivative, and you can see this we have only first derivative, so it's the it's a differential equation of the first order. Make sense? Okay guys, that's it for this video. How was it? Was it hard? It's an introduction to differential equations, right? So just to sum it up, we talk about the differential equations, right? What they are. So right now we, if somebody asks you what are differential equations, so you can answer them now. Not only that, you can tell them which one is the ordinary differential equation and which one is the partial differential equation, right? And whether or not it's linear, you can tell that as well. And what's more, you can also tell the orders of the differential equations, right? The orders, the order of a differential equation is the highest order of the derivative, right, of the equation. And after that, we talk about the solutions, right? The equation, or the y is the solution of the differential equation, is when you substitute y into the the differential equation and it's correct, right? You can verify the differential equation by substituting y. And the last thing, we talked about the differential form, right? dy by dx equals box. We have that dy is actually box of dx. That's the main idea, right? So from now on, we usually use the differential forms. So if you have any problems regarding these what we have been studying, just text me, okay? And just ask me. I know that it can be tough, it's gonna be harder later on, so better not to leave it, okay? If you come across any problems, any questions, things that you don't understand, help is here. Okay, so see you in the next clip. Bye bye.